Okay, so today what we need to talk about is binomial probability, or Bernoulli's experiment. What this is about is when there's only two possible outcomes, success and failure. We call the probability of success P and the probability of failure Q, just to have some variables to represent that. Something important to note is that P plus Q has to equal 1. So the probability of success and the probability of failure has to be 1, which means that all probability is accounted for. There's no gray area here. Okay, so here's an example. You have some marbles in a bag. 3 are blue, 4 are red. And what you're going to do is you're going to pick a marble, you're going to record the color, and you're going to put it back. Pick another marble, record the color, put it back. You're going to continue to do that. What that does is it preserves the probability of picking red and picking blue. So with each pick, the probability stays the same. That's very important with binomial probability or Bernoulli, because you need to make sure that the probabilities of each pick are completely independent, which means that the previous pick does not influence the probability. So what we're going to do here is we are going to pick 5 marbles with replacement. So you're going to pick a marble, record the color, put it back. You're going to do that 5 times. What I want you to do is find the probability that exactly 2 of them are red. So the first thing we need to do is find the probability that you pick a red marble. And so because we know that there's 7 marbles and 4 of them are red, I can tell you that the probability of picking a red is 4 out of 7. The probability then of picking a blue marble is going to be 3 out of 7. Probability of picking a red is going to be our P, which is our success, because that's what we're trying to do. Probability of picking blue is going to be our Q, because that is our failure. Okay, so here's the way it goes. I want exactly 2 of them to be red. So the easiest scenario is probability that the first marble I pick is red would be 4 out of 7. The probability the next marble I pick is red would be 4 out of 7. Then the next marble would have to be blue. If only 2 of them are going to be red, then I would have to have a blue marble and another blue marble and another blue marble. So here is the probability that the first 2 are red and then the next 3 are blue. Okay, and I can put that down. These would be the red and these would be the blue. So I can write these exponentially. It makes it a little bit easier. The probability that I picked 2 red is actually going to be 4/7 squared, because I need red times itself. And then the probability that I pick non-red or blue would be 3/7 cubed, because there's 3 factors of that. When I calculate that, I actually get 432 over 16,807. Okay, so that's the probability that it happens in this order. So the probability of getting red times a red and a red and then a blue and a blue and a blue is 432 over 16,807. Here's the problem. It doesn't necessarily have to be in this order. And so what I need to do is figure out, what if it doesn't happen in this order? What if I get a blue first, and then a red, and then a blue, and then a red, and then a blue? That's also exactly 2 out of 5 reds. Or what if I get a blue, and then a blue, then a red, then a blue, then a red? Or maybe I'm going to get a blue, then a red, then a red, then a blue, then a blue. Or I could do red, then blue, then blue, then blue, then red. Or possibly red, then blue, then red, blue, blue. I could do this until I figure out every single way ordering these, which is a permutation. But because of the repeated R's and B's, it's a permutation with repetition, which we talked about is kind of like a combination. So what I could tell you is, if I take the combination of 5 things, because I'm picking 5 marbles, but I want 2 of them to be red, then I can tell you that that will end up being 10. So if I continued to list these orders here of red, red, blue, 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 red, blue, red, blue, red, blue, 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 red, blue, if I listed them all, I would end up with 10 of them. Okay, which means for every single order, this one and this one and this one and this one and this one, each one of these is going to have this probability, because this probability is for 2 reds and 3 blues. That's where those numbers come from. And on each of these I have 2 reds and 3 blues. And we know multiplication is commutative, so the order in which you list these factors is not going to affect the end product. So if I'm going to have 10 of these, that means, and when you hear yourself saying or, this could happen this way, or this way, or this way, or this way, or this way. That means we add all those together. So instead of adding this 10 times, I'm going to simply multiply it by 10 for the combinations, all the different ways it can happen. Okay, that would end up giving me then 4,320 over 16,807. That would be my final answer. So there's actually a formula for this. This is what it looks like. This is the combination of n things r at a time. So in the last case I had 5 picks and I needed r successes. Probability of success r times, and failure, the difference between them. Okay, so some important things to remember. P represents the probability of success, which means it's what you're trying to get the exactly works. And Q represents the probability of failure. Remember that P and Q together have to equal 1. And then R is the number of successes, and that goes in 2 spots. It's here with the combinations, and then it's also the exponent on the probability of success, because you know, in the last example we wanted the probability of picking a red 2 times. So it would be a red times a red, or exponentially, probability of picking a red 2 times, and then a blue. The difference between the 5 and the 2 makes 3. Because again, those have to add up to the total picks. So let's look at another example. So in this example, I'm going to tell you that the probability of rain is 2/5. Sometimes they do this as a percent, sometimes they do it as a decimal. So whatever format they give you the answer, or the phrase the question in, opens up the format for the answer. Just know that. So if the probability of rain is 2/5, find the probability that it rains exactly, and that's an important word right there, that exactly. And then you're going to look for this phrase, 3 out of 4, or 3 out of the next 4, because this is what sets up your combination. 3 out of the next 4 is going to be your combination, and this number here is going to be your n, and this number here is going to be your r. So I want to set up my combination for choose 3, because that's going to give me all the different ways that I can arrange rain, 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 no rain. Okay, it's only going to be 4 different ways. So if I come up here and use this format again, what I'm going to say is, okay, so out of the next 4 days, it's going to rain 3. In this case, rain is the success because that's what I'm looking for, raining exactly 3 out of the next 4 days. So out of 4 days, it's going to rain 3. I need the probability of success, which is P, so that's the probability of rain, and in this case, that's 2/5. And it's going to rain exactly 3 days. So it's going to rain, and then rain, and then rain, and that's why we have 3 factors of that. And then the probability of failure, which is not raining, and I know that seems backwards, but that's the way this one works. You have to figure out the difference between 2/5 and 1. So if you understand that the probability of raining is 2/5, and then hopefully you realize that the probability of not raining is going to be 3/5. And we could actually name those. That the P, which is the probability of success, is going to be 2/5, which means that Q is going to be 3/5. Because again, those have to add up to 1. So that's going to go into the second parenthesis. And if it's going to rain 3 out of 4 days, then it's going to not rain only 1 out of those. So what I look for, do these two numbers add up to my total number of days that I'm looking at? And then does my number of successes match the number I'm choosing here? Okay, that's how you set it up. From there, we're just going to calculate this. So just watch these, your order here. You're cubing both numbers, numerator and denominator, and multiplying. Sometimes your calculator can handle this. If your calculator is going to give you a decimal display, please make sure you write the whole decimal, that's all. So I can tell you that 4 choose 3, the combination of 4 things 3 at a time, is going to give you an answer of 4. If I take my 2/5 to the third power, that will give me 8 over 125. And 3/5, of course, to the first power is only 3/5. Now again, remember, when you're multiplying this 4 is part of the numerator product because it's technically over 1. So please don't multiply it by both, or just let your calculator do it. But what you're going to end up with here is a 4 times an 8 times a 3, which ends up giving me 96 over 625. And that's the probability that it will rain exactly 3 out of the next 4 days. Okay, one last example. When rolling a fair die, what's the probability it will land on a 5 exactly 2 out of 3 rolls? So again, what we want to do here is we want to look at the probability, and this time I have to figure out the probability. So the probability of rolling a 5 on a fair die is 1 out of 6, which means that the probability of not rolling a 5 is going to be 5 out of 6. Okay, what that will equate to then is that the value of P is 1 out of 6 and the value of Q is 5 out of 6. Now the other thing I need to look for is this phrasing right here, 2 out of 3 rolls, and that's my combination. That's going to identify my N and my R, or my number of successes. So when I put this together, it's going to be the combination of 3 rolls, and I need to get 2 5s. So this is my success here, this is my R, this is my N. Okay. Probability of success, which is my P here, is going to be 1 out of 6, and I need that to happen twice. And then the probability of failure here is 5 out of 6. That's this one. That's my Q. And if out of 3 rolls, if I'm getting 2 5s, that means the difference between them is I'm going to get 1 roll that's not a 5. Setting up this notation is the hardest thing. Hopefully you're following along what it is I'm doing and it makes sense to you. If not, please bring those questions to class tomorrow, and then we will try to straighten it out. And again, part of it is just practice and getting used to where these numbers go. So when I do calculate this now, 3 choose 2, turns out to be 3. Whoops. And then 1/6 squared is 1 over 36. And 5/6 to the first is just 5/6. So again, when we multiply, remember the 3 goes to the numerator. This gives me 15 over, let's see, 36 times 6 will be 216. And this is going to be the probability. Okay, so hopefully that makes sense. And like I said, we'll be practicing in class.